Jai Hind everyone. My name is Gunjan Saxena, Assistant Professor, Ajay Kumar Garg Engineering College. I am Assistant Professor in CSC Department. Today I am here to just brief second lecture in software engineering subject, and the topic is requirement engineering, and after that I am discussing about the DFT. So firstly, what is requirement engineering? In my last lecture, as I discussed the SRS, what is SRS? SRS is software requirement specification. What is that? If we are making any software, or we can say any product, we have to write down, or we can say we have to discuss about the basic requirements, what the user actually wants. Okay, so in this particular, we have to say, after discuss about the requirements, or we can say the target, what the user exactly wants, the software developer, or we can say the project manager, have to discuss about the complete requirement. Okay, in this particular session, we have to discuss about the specific topics, specific data, the current technology, the basic things, what is the functionality the user wants, what is the what maybe the future scope. All these things should be discussed. Okay, so in short, what is requirement engineering? Requirement engineering refers to the process of defining, documenting, and reviewing requirement in the software engineering design process. Requirement engineering provide a appropriate mechanism that understand what the customer desires, actually what exactly customer needs, what is the basic funda behind this particular product, what is the current approach of the user. These all things are defining in this particular term. Thus, requirement engineering is a disciplined application of proven principle, method, tools, and notions to describe a proposed system's intended behavior and its associated constraint. Now, what are the types? Basically, the requirements are three types. Some are known requirements, some are known, some undreamed requirement, or we can say, as the user perception, requirements can be divided into two types: functional and non-functional. What are that? In functional requirement, we can say the statements of the service of system should provide how the system should react and behave in certain conditions. That means if I am making, or we can say simply, I am just purchasing a watch, and we are just thought about the smartwatch. What are the functional requirement in the smartwatch? As I required, the time is displaying, and our body fitness, BP is there, and the pulse is there. These are the functional requirement. What is the non-functional requirement? Basically, non-functional requirement are that type of properties such as reliability, response time, availability, not concerned with any specific functions delivered by the system. That means if I want a BP, I'm just checking my BP, then what is the response time? The watch should be give quickly the BP. Okay, so this is the non-functional requirement. What is the domain requirement? Requirement that come from the application domain of the system and that reflect the characteristics of the domain is known as a domain requirement. Now, in this particular slide, I am just giving a small comprehensive between the both functional and the non-functional requirement. Basically, if I can talk about the functional requirement, it is mandatory, and the non-functional, which is not mandatory. As we can say, I need a smartwatch. Okay, and this are the functionality, and this color is blue. The color is blue is just like a non-functional requirement. Okay, capturing type, it is a captured in use case, and in case of non-functional, this is the quality attribute. Okay, easy to capture functional requirement, hard to capture non-functional requirement, and all the others just you can go through it. Okay, Now, the basic functional requirements like some legal requirements, some business rules are there, administrative functions are there, data managements are there, external interface, audit tracking. These are the functional and non-functional requirements. Okay. Now, this is the process behind the complete requirement engineering process. Now, see, after the feasibility study, so first I have to know, or we can say I have to discuss about the feasibility study. If we are making a system or we are planning to make a system, then we have to know about the system feasibleness. And what that? Feasibleness is basically the system we are going to deploy or we are going to make. Then the system is operationally feasible, the system is financially feasible, or we can say the system is technically feasible. After all the proven of these particular things, then the feasibility report is generated. After the feasibility study, the feasibility report is generated, by which we can ensure the system we are going to develop is completely feasible. After the feasibility report generation, we have to move on the very first step of requirement engineering. The name is requirement elicitation and the analysis. What was that? In this particular phase, we are just developing the different system models, or we can say by using this particular level or steps, we are just gathering the information. So many types of pattern, or we can say so many types are there for elicitate the particular requirement. Just we are gathering the data from different resources. After that, we are going to the analysis phase. So, after the elicitation, we are just specify all the requirement. The specification means user and the system requirement, what the actual demand of the particular user and the particular system, these requirements are recorded in this particular phase. After this requirement specification, we have to go to the validation phase. The two things are very important in this particular process, the verification and the validation. So, what is the verification and what was the validation? I will discuss in the next slide. After the validation, what we are making and what we are getting. So, if both are the equal, then we can say our system is validated. After that, the portion of requirement document, the name is SRS, is going to be start. Okay. So, in brief, requirement engineering process, as I have discussed in particular diagram, we are just go through what is the elicitation process. In the particular topic, it is basically it is a way to collect the information, or we can say the gain, we can gain the knowledge about the project domain and the requirement. The various sources of the domain knowledge include customer business module, the existing software of same type, standards, and other stakeholders projects. Okay. So, there are so many types for requirement elicitation process. It will includes interview, brainstorming, task analysis, and many more. Okay. Next is requirement specification. What is that? All the requirement, including the functional as well as the non-functional requirement and the constraints, are specified by these models in totally during specification. More knowledge about the problem may be required, which can again trigger an elicitation process. The model used at this stage include the ER diagrams and data flow diagram, etc. Now, next is requirement verification and the validation. So, as I discussed earlier, or I earlier said, the verification and the validation both are very important topic in software engineering. So, what was that? Verification, it refers to the set of task that ensures that the software correctly implements a specific function. And what is the validation? It refers a different set of tasks that ensure that the software that has been built is traceable to the customer requirements. Okay. So, in short, we can say the requirement should be complete in every sense, and the requirement should be practically achievable. Okay. So, what is verification? What we are making if we are making the good product or correct product, we are checking in every stage. Okay, and what are the validation? In terms of validation, after completing the our system, we are just validate, yes, I want this system, and yes, this is exactly that one. Okay, this is the validation. Now, the next is requirement management. The requirement management is the process of analyzing, documenting, tracing, presenting, and the requirement and the control, the communication to the relevant stakeholder. This stage take care of the changing nature of requirements, being able to modify the software as per the requirement of systematic and controlled manner in an extremely important part of the requirement engineering. Now, as I already discussed about the elicitation, I just brief up the type of elicitation method: interview, brainstorming, QFD, that is the quality function development, and use case approach. So, what are the interview? Objective of conducting an interview is to understand the customer's expectation from the software. Interview may be open-ended or structured. What is the open-ended? Open-ended basically where, as per the agenda, context-free question may be asked to understand the problem. And structured interview, agenda is fairly open, question is prepared. Sometime a proper questionnaire is designed for the interview. Brainstorming, basically it is a group technique. It is intended to generate a lot of new ideas, hence providing a platform to share views. A highly trained facilitator is required to handle group-wise and group conflict. Every idea is documented so that everyone can see it. Finally, a document is prepared which consists of the list of requirement and their priority if possible. Okay. So, what is the problem? Less knowledge of technology. Problem kahan hai? What is the problem? Less knowledge of technology, use of different language by the developer and the user, lack of skills in developer, user not providing some information due to some reasons. Okay. Now, the term is feasibility study. Basically, feasibility study specified whether the proposed software project is practically possible or not. Basically, we are going to develop a software, or we can say a system. We are just checking the particular system is possible or not. Whereas there arises a need for any software, you cannot directly jump in developing the particular software. Instead, we must first analyze certain facts to realize whether the software is possible or not possible. Is it called as feasibility study? The type of feasibility study: technical feasibility, operational feasibility study, economical study, legal feasibility, schedule feasibility. What are that? Technically, the particular system is technically possible or not. About the operational, in terms of operation, the particular system can perform the operational very well or not. In case of economical, within a budget, the complete system is in user budget or not. Legal, in terms of legal feasibility, make sure that the product complies with all the regulations and the legally possible things. Okay. Schedule feasibility, the particular system, or we can say the particular product, is complete within a time or not. Now, next is information modeling. After the requirement gathering, or we can say requirement handling, we have to go to the requirement specification, as I discussed in the diagram. Okay. So, after the requirement gathering, we have to specify or just model the things, the very first step. And by for using the information modeling, we have different type of techniques like ER diagram are there, and the DFDs are there. In today's video, I am discussing about the DFD. Okay. Then what is the information modeling? An information model in software engineering is a representation of concept that are relationships, constraint, rules, and operation to specify data semantic for a chosen domain of closure. Typically, it specify relationships between kinds of thing, but may also include relations with individual things. It can provide the shareable, stable and organized structure of information, requirements and knowledge for the domain context. Okay. So what is the DFD? A data flow diagram is a traditional visual representation of the information flow within a system. It shows how data enters and leaves the system, what changes the information and where the data is stored. The objective of the data flow diagram, or we can say DFD, is to show the scope and boundaries of a system as a whole. It may be used as a communication tool between a system analyst and any person who play a part in the order that act as a starting point of redesigning a system. The DFD is also known as data flow diagram, or we can say data flow graph or bubble chart. So, in short, what is, as the name suggests, data flow diagram. If we are making a system, obviously the flow of the data, or we can say flow of the information, is showing step by step. So, DFD is the way to represent our system. Here, we have to represent, or we can say we show our system in three different manner, or many more actually. So, the very first manner is context DFD. By using this context DFD, we are just representing a best view of our system. Okay. After then, the level of these particular DFDs increases. How the level of this particular DFDs increases? The level of DFD is also showing the complexity of our system, or we can say the exploring our system step by step or level by level. Okay. So, first of all, we have to discuss, quick discuss about the symbol of the DFD, what we are using. Basically, in terms of data flow, if we are representing the data movement from which side the data is going to, or we can say the information is going to, these simple line, these straight line are showing the data flow, which is used to connect the process to each other, to the resource, to the source and sink. Basically, what is the source and what is the sink? From the starting, we are just starting from the data movement is called as source, and the destination part where we have to go, the name is sink. Okay. So, process which is represent using the circle, simple circle only, basically perform some transformation, or we can say data. If we want to represent about the input data and the output data, we are just using this particular circle. Now, as I already discussed about the source and the sink, or we can say the external entities, so we are using this particular rectangular box. A source of system input, or we can say the sink of system output, is representing through this particular rectangle box. Okay. Now, if we are showing the data to be stored, if we are saying the data is storing, or we can say the data is retrieving, then these two lines, and by using these incoming and outgoing data, is represent the data stored. So, basically it is a repository of data. The arrow heads indicates the net input and the net output to be stored. Now, some rules are there. What was that? If we can say the data can flow from, we can say, in the last slide, as I discussed the internal entity and the process, the entity is simple rectangle, then data flow, then entity to any process is possible, or just vice versa, we can say the data process to any entity is again required, or we can say the valid. Process to store and back is also allowed, and process to process is also allowed. Then we can say the flow of data is rule for the movement of the data from external entity to process, or we can say process to external entity, process to store, and process to process, which is okay. Data cannot flow we can say any external entity to any external entity. That means there is any external entity, we can say some students are there, and the data is directly flow student to teacher, which is not acceptable. External entity to store, suppose this is the external entity and we are saying the data is directly go to the store, data store, which is not possible, and the vice versa is data store to entity, which is not possible. Store to store, any store is any store to directly go to the any data store, not possible. That means the movement of any data is required a process. By using the process, different type of process, or we can say the mediator of process, the process entity is very, very important. Now, some different type of level, or we can say the level of the DFD, there are 0, 1, 2 and beyond the levels. Beyond actually how many depth are there, you can or clarify or briefify your system. So DFD may be partitioned into levels that represent increasing information flow and functional details. Levels in DFD number may be 0, 1, 2 and beyond our requirement, right? Level 0, what was that? It is also known as fundamental system model, or we can say the context diagram, represent the entire software requirement as a single bubble with input and output denoted by incoming and outgoing arrow. Simply a simple bubble, or we can say single bubble. In this particular slide, I am just taking the simple example of railway reservation system. So obviously, this is the bubble diagram, or we can say zero level diagram. There is a simply bubble railway reservation. Passenger side is there. Obviously, this is the source side, or we can say the entity, and there is an admin who is just collecting the request and just work on it. Maybe some reservation is already there, then the passenger wants a cancellation, or we can say some reservation. Then railway reservation, maybe just reservation cancellation info, or maybe some passenger info. And if the reservation process is done, then up down train information is there, and after that by using this bubble, the ticket information maybe go to the passenger. So just this is the level 0 diagram. Now come to the level 1 diagram. What was that? 0 level DFD is decomposed in multiple bubbles. The last, in this particular last slide, this bubble is decomposed in multiple bubbles. So part of the system represented by each of these bubble are decomposed and documented as more and more detailed DFD. For example, the reservation process is further divided in inquiry, ticket generation process, report to admin, some data stores are there. So this is the level 1 DFD. After that, the level 2 DFD. What was that? This process may be represented at as many levels as necessary until the program at hand is well understood. It is essential to preserve the number of input and output levels between. Thus, if bubble A has two inputs x1 and x2 and one output y, then extended DFD that represent A should have exactly two external input and one output. So इनपुट एंड आउटपुट आर नेवर चेंज. बस करना क्या है कि हम इन बबल्स को और क्या कर सकते हैं, और हम एक्सटेंड कर सकते हैं. दिस इज नोन एज लेवल 2 DFD. ओके, now this is again a further next context level diagram for food ordering. This is the another example. Many more examples are there. What you can do, you just take any problem, any running problem, and just try to make yourself DFD. Maybe your DFD and my DFD are different, maybe just thinking criteria, or we can say the level of capability. So this is the level 1 DFD and this is the level 2. If we are, this is the one, the processing of the order, which is the 1.0. What is the level 2? We are just exploring the 1 point. So get an order and prepare a bill. 1.1 and 1.2. Again, you can just use your capability and try to further decompose this particular bubble, update sold item file, update inventory file, generate the management report. Okay. So this is all about the DFD. At last, just type of DFD. Basically, DFD divided into two parts. Some logical views are there, some physical views are there. Logical views, or we can say logical DFD, basically focus on the business and how the business operates. And the physical level DFD, it shows how system will be implemented. Okay. So just for a quick sum up, in today's video or today's lecture, I'm just brush up about the requirement engineering. After finishing the lecture on SRS, I have to discuss about the requirement engineering. What are the requirement engineering process? What are the different steps in their elicitation, then the requirement specification, then the validation, and after that the report generation. Okay. After that, when we are completing the requirement, as I know about the functional and non-functional requirement about our system, then the next step is specification. We are just move up to the designing model, or we can say just specify the different specification. For the specification, or we can say information modeling, we have so many types of there, like ER diagrams are there, DFDs are there. In today's presentation, I just pick up the DFD. Basically, the data movement from one point to another point is representing by using the data flow diagram. So different levels, or we can say different involvement of the system or the explorement of the system is level up by using the DFD. Like 0 level DFD is the very quick review, a single bubble, a single entity at the source side, single entity at the sink side, and the single bubble is there, is a 0 level DFD. And again, the level upping the DFD, we are just exploring the bubble, or we can say decompose this bubble, or possibly more bubbles. Okay. So, okay. Thank you for watching. Wait for next video. Okay. Jai Hind.